Hey guys, welcome to Code Decode. In this video, we are going to look into Java 8 interview traps for 2026. Usually, these questions are asked by interviewers to trick you around to find out whether you know the deep basic concepts of Java 8 or not. So let's get started and see such traps which are created to confuse you. So let's get started. The very first trap is, does the streams execute line by line? Let me give you an example what he's trying to ask you. Suppose there is a list 1, 2, 3, 4, 5, and this is a code which works upon this particular list. Where you stream above it, you filter only those elements which are greater than 2. Then you map those elements to their multiplication of 10 and at the end return the first one. So what most of us thinks is that all the elements 1, 2, 3, 4, 5 goes through this filter, fetches 3, 4, 5 only. Then those 3, 4, 5 are mapped to x into 10, that is 30, 40 and 50, and then 30 is returned. If that is what you think, that the filter operation happens with 1, 2, 3, 4, 5, then map happens with 3, 4, 5, and then at the end find first happens. This is not how stream works. Most of us does think in the same way that stream executes line by line or operation by operation, but the answer is not true. This is not what actually happens. You think of stream as a conveyor belt you'd see in the airports. What happens is when you put your luggage into it, it goes till the end. So each element goes through the whole pipeline before the next element is touched. For example, in the step 1 for this, let me copy this for you. Now, how does this stream actually works? The 3 operations were, let me copy this also for you. The first operation was filter. So the first element, that is 1, goes through all the 3 steps in the pipeline, that is filter, map and find first, and check, is 1 greater than 2? Answer is no. So 1 is discarded then and there. Map and find first is never called. And that's how second is not touched yet. In the second step now, second goes through this whole conveyor belt. It goes through filter and checks, is greater than 2? No, it is equal to 2, so it is again discarded. Now the third element, that is 3, goes through this filter. It says, is it greater than 2? Yes, 3 is greater than 2. Then the map operation occurs where 3 into 10 happens, which is 30. And then find first also occurs. And find first is a short circuit operator. That means as soon as it finds 3 greater than 2, it multiplies it with 10, maps the whole list with 30, short circuit everything else, and returns. That is, it is found. Find first happened. So first find first finds a value. The stream stops immediately. And 4 and 5 is never touched. So because of this short circuit operation, 4 and 5 never touched. 1 never reached till the end. 2 never reached till the end. 3 reaches to all the conveyor belt, reaches the end, short circuit happens, and that's it, where it ends. The stream ends. So the full output becomes 1 goes only till the filter, 2 goes only till the filter, 3 goes through filter, map and find first, and that is it. Now because the first filter runs for all the elements, then map runs for all the elements, this would be the wrong part. This is not true for the stream because streams are lazy evaluation. These are short circuiting. So find first is short circuit operator and element by element execution. So you have to remember this. Whenever stream comes into your mind, what thing should come into your mind is airport's conveyor belt. Each luggage goes to the whole pipeline, whole conveyor belt from start to the end. And then the second bag or the luggage is entered onto the conveyor belt. What is the advantage of it? Because of lazy evaluation, performance increases, logging is better, side effects are less, and debugging is changed. So streams do not run by stage for all the elements. They run element by element and stop as soon as the terminal or the short circuit operator is satisfied. Hey guys, recently we have launched a course covering an end-to-end full stack application using Angular as front end and microservices and Spring Boot as the back end. Also, we have used Cloud to deploy this application, and we have used CI/CD, that is Jenkins and Argo CD, for continuous integration and continuous deployment. The technologies that we have used is REST, RESTful web services, Spring Boot and microservices for backend, Angular for front end. GitHub we have used for version control system. Also, to make the code unit testable, we have used JUnits. We have used Sonar for code quality checks. Also, for containerization, we have used Docker and Kubernetes. And to deploy this whole application, we have used AWS and multiple services from AWS. Also, we have used SQL as well as NoSQL, that is MongoDB and SQL. On AWS, since for the SQL we have RDS, we have used those services, and Jenkins and Argo CD for CI/CD pipeline. Also, this is an architecture of the application that we have created where the front end is Angular and the back end is microservices. We have used ALB load balancers, Ingress for routing and load balancing. And we have used SQL and MongoDB for SQL and NoSQL DB management with Eureka Server and all those microservices counterparts. Now, this is the CI/CD pipeline. This is the CI/CD flowchart for the application that we have created on local. So, this is something, a flow when you create an application in local, push it to GitHub, create a Jenkins pipeline, and do the CI/CD using Jenkins and Argo CD. And at the end, deploy the whole code at AWS EKS. Complete description of this course is covered in a very separate video. The link for that video is also given in the description bar below. And also the link to purchase that course from Udemy is also in the description bar below. So please go and check the description for all these links. The second trap that you find in Java 8 is, does find first always return the first element? And we think about it, yes. But what we forget is there is some concepts of parallel stream. Now suppose you have 1, 2, 3, 4, 5. If parallel stream would have run over it, and two threads simultaneously picked 3 and 4. 1 and 2 were discarded in the filter. Now 3 and 4 were the two threads running. But the second thread, which is having 4, reaches to map and find first. Then 4 is what comes into the list or the output as 40, because 4 is greater than 2. 4 into 10, that is 40, and find first occurs even before the thread 1, that is 3, reaches to find first. The thread 2, that is 4, reaches to the find first, and hence the output becomes 40. So if you think the find first will always return in the deterministic order of 1, 2, 3, 4, 5, remember to check what stream are you using. Is it the normal stream or the parallel stream? If the parallel stream, then 3, 4 or 5, anybody can come as an output. So the find first is not deterministic. It is depending on the which thread matches the first and reaches to the end first. This means the result can change between multiple runs in a parallel thread, and we think that parallel stream should behave just like a loop and in a deterministic order, which is not true. So always think what parallel stream or what type of stream are you using. Is it a normal stream or a parallel stream? Now the third trap is parallel stream always faster? What is the thinking what we keep? That parallel stream means more thread, which is true. Now more thread means more work, which might also be true. So it must be faster also, because internally 3, 4 and 5, all the 3 might have been taken of the 3 cores, and whoever reaches first to the find first becomes the short circuit operator, and that becomes the output. But that is not true. Not always parallel stream means it is faster. It is purely true only if it is pure CPU work. But in our Java 8, we just don't work upon these CPU or system.out.printlns. The real backend system works upon blocking calls. Even system.out.println becomes a blocking call. Even the database or IO calls can be a blocking call. HTTP REST endpoints are blockings. File IO and messaging queue might also be the blocking ones. So real backend application might not always depend upon non-blocking ones. They can be blocking ones. And if they are blocking, and then you are using the parallel stream on blocking calls, you are in very much trouble. Let's see why. So you thought we have multiple orders. Let's call a remote service to process these orders. But the remote service call can be blocking or non-blocking. If it is non-blocking, it is fine. You raise multiple threads. The multiple threads works in parallel. They process your orders. You are good. What happens if remote call is a blocking call? Now this parallel stream, what it will do, it will use the threads which are available in join fork pool, which is a common pool where threads are available. Now this pool is also used by completable futures, some internal work and some parallel streams. So this pool might have roughly number of CPU cores is what the number of threads are. Suppose you have an 8 core machine, then you have around 8 threads. Now what happens with this parallel, let me copy this code for you. Now what happens if this is a blocking call? Each thread wait for a response. So if 8 orders comes in parallel, 8 threads will be spawned up from the common pool of threads. Then all the 8 threads will wait for the remote REST API call. What if the REST API call blocks for a long time? Now thread is not doing any work, but it is still occupied because it is waiting for call remote service method. And it cannot take any other task. So at a time, only 8 orders can be processed by a parallel stream. Now imagine 8 threads, 8 orders sent, all of them are waiting for remote service. Now pool is now fully blocked. You do not have any more threads. Now the 9th order comes, it waits in the queue because parallel stream is trying to create thread, but thread is not available. Work is queued, application is slowed down. And at a time, the entire code is slowed down and the entire JVM is very slow. Now, this is a production killer. Why? Because when it is a dev or local environment, you might not even know about it. The reason being, the load is very less. But when you go to production, a lot of orders comes into the real time, right? So request threads calls the business code. Business code uses parallel stream. Parallel stream uses the common thread pool. The thread pool is all the 8 threads are blocked. Request is hanging out. Only 8 requests were able to be processed. 9th request and so on are hanging out. User sees timeout. User sees that running timer button, but nothing happening. Everything looks fine in development because load is very less. But everything breaks under production where load is very high. So the summary is parallel stream seems to help you a lot that your orders will be processed faster. But the fact is the parallel stream uses the thread in a common pool. So the blocking operation can freeze the entire application. And hence, then we see a real system failure in such situation. So not always parallel stream is always helpful for you. When there is a heavy load, rather than going to parallel stream, you rather go for non-blocking IO calls like reactive programming, virtual threads, and so on. Now comes the 4th trap. Can streams be reused? Now this is where the real problem lies. We would think, what will this code do? So suppose you have a stream of integers, like 1, 2, 3, 4, 5. You open a stream over it and then you print each of them. Now you say, okay, now on this 1, 2, 3, 4, 5 list, I want to make it multiply by 2 and then print again. Can you reuse the S which you have already used for system.out.println? Most of us things says that, okay, since it is a local variable, I can reuse this stream for multiple times. But what you are considering is that stream is not a list of data or a collection. It is just a pipeline which consumes the data. So your thinking is wrong. You cannot reuse any stream variable again and again. Because stream is not data or a collection of data, or it is not a collection. It is just a pipeline that consumes the data. So internally, what happens here? Let me copy the code for you. So now what happens here? We have a list 1, 2, 3, 4, 5. We open a stream over it and we name it as a local variable S. Now when you try to print over it, it will 1 goes through the whole flow and prints it. Then 2 is printed, 3, 4, 5. So this stream is going to pull each of one element from the data, process it and discard it. So each element flows through the whole pipeline. The terminal operation consumes it, and when it is finished, and when terminal operator runs system.out.println for 1, 2, 3, 4, 5, the stream is closed. Now, if you want an analogy, you think of it as a water pipe, which you use for gardening. Once the water flows through it, reaches to your plants, the pipe's work is done. When you closes the tap water, that is it. Your water is gone. Now, if it would have been a water pipe, you have to discard that water pipe then and there after gardening. You cannot reuse that pipe again for gardening. So even if you try to again do S dot for each element, map each element with multiply by 2. So you are expecting 2, 4, 6, 8, 10. Output will be stream has already been operated upon or it is closed. This is because pipeline is already consumed. There is nothing left to process and hence it was closed because 1, 2, 3, 4, 5 was completely processed. Reusing it would either give you an exception like illegal state exception or inconsistent behavior. Now you'd ask me why? If it would not have been stream, if it would have been a simple list of integers, then I could have used L for n number of operations because L you thought of is just a collection of data. But stream is not a collection of data. Why Java enforced this kind of design that once stream is operated upon, stream will be closed and will never be reused? Because in real world, this does not happen. You can use the same water pipe to garden again and again. But what Java says is if you have used this water pipe to garden your plants, you can never use the same pipe to garden the same or the different plants again. The reason is streams are designed for lazy evaluation and it is one-time traversal only. If 1, 2, 3, 4, 5 reads the terminal operation, that is for each, it will never start from anything. And also it is designed for parallel execution. If Java would have allowed you to use it, then it would have to buffer 1, 2, 3, 4, 5 because since it reached to the end, now how will it start from scratch, right? So it will be a disaster on the memory size. Memory usage will explode if streams keeps on recording or buffering all the data. Laziness would be lost. So for this reason, Java made sure that one stream is only one traversal. If you're using one pipe to filter your plants, never reuse it again. And why this is a trap? Because most of the developer, what we do is, we just do list.stream.system.out.println. We never store this stream in any variable. What we do is we just list stream, apply multiple filter, map, and at the end a terminal operator. And hence we never see the exception that this stream S is never stored as a local variable. And that is why we never know that the exception can come if we reuse it. So stream is just a one-time pipeline, does not a data structure or a collection of objects or datas. It is just a one-time pipeline. So once a terminal operation runs, stream is consumed and can never be reused. If you reuse, either you get an exception or an unexpected behavior. Now let's think about the fifth trap, and which is very important when it comes to Java 8. And 99.99 people give a wrong answer to this. So is the optional replacement for null? Most of the people think so. But that is not true. If you wanted null pointer exception to be removed, you thought of using the optional. Maybe you're doing it wrong because this usage of optional is not a replacement for null. It is rather just going to keep that bug that you have created for a long term, even in production, without breaking your application. It would have been better if you kept it null rather than optional because I'll give you reason why. Now, most candidate thinks I use optional, so I no longer have to worry about the null, which is very false because optional does not remove null. It just hides it in a box. So what optional does is it just hides your null value in a box called as optional.empty. Now look at this code. What does this code do? You might have some method in the DAO layer where you find the user from database, you return an optional user. Now, this optional of user, that is this user, either can be a box with a proper user object with name, ID, address, everything, or it can be an empty box if database has no user for this particular ID or something. Then it would have been optional.empty, that is an empty box with nothing inside it. If in case, even if you get the user into it, you try to get the name of that user in the optional of string. Now, even if you get an object of user in the database, what if the name is null? Then either you have a box of empty name, that is optional.empty, or you might have some name like codedecode. So most developer thinks that what it does is get the user and get the name. But what actually happens? This user is going to be a box of user object if the user exists, or it can be empty if no user exists. So now user can be a box with user inside or an empty box. But now what does this map do? It is not just a user.getUser method call. It means that if value exists into this optional, then apply the function of getName. If no value exists, then return an empty. So this name is going to be optional.empty if there is no name in the user. So you get the user object. In both the scenarios, step 1 and step 2, you got the user. If you got the user, if the user is present, then call the get name, take the result, wrap into optional. But the second case, if the user is not present itself, again it will return you optional.empty. So what does this user.getName returns? Null. The user is not having any name. There is a user present. That is user u equals to new user. There must be a user in the database. But the name of that user is not code decode but rather null. Then what does this code do? The getName returns null. What does optional.map do? It does not create optional of null. This is illegal. It silently converts into optional.empty. So now you have a user, but the value of the user is disappeared. Why? Because you called user.getName. The null was empty. So even if you had the user entry with ID, address, and everything in place, you mapped it to its name, which is empty, and you silently completely removed the existence of user object because the name was empty. No exception throw, no null pointer exception, no error logged, the data is silently lost. Your program continues but with the missing data. So you thought of using this user object going forward, but you are lost because what you have done is you mapped it to the empty one. Now, why is this dangerous than null? In this case, I would have thought to rather keep it empty or null pointer exception was better, because at least you get to know why your program broke, because your user is there but the name, which was compulsory field, is not there. So null would have crashed your program. But now, since you have used optional of null, it is optional of empty. Optional hides the null value, that is compulsory name which should be there for each user is now he hides the null and lets your program continue in a broken state. Because even if you had the user, now what you have in your box is optional.empty, which is of no use. So this is much worse. Now your code might skip the logic, skip the validation, skip the database update, because now if you want to try to update the user, you don't have the name of it, you don't have any placeholder for it, you will never be able to do any update. You will skip a lot of logic without any visible error or exception. The optional was created to make the absence explicit and force you to think about the missing values, but it was not designed to replace the null used as a field or to be used anywhere and everywhere. Optional is not about removing nulls, it was about making the missing values visible and intentional. Now, since you have used in this bad manner, you have blindly injected a bug into the code, and now this bug is very hard to detect and debugging is very difficult. So optional does not remove null, it just convert into the empty boxes, which generally what it does is it silently hide the bugs in the production. So using optional just for the replacement and removal of null pointer exception is a disaster, because at this point of time, I think null pointer was better because it at least tells you where it and why it fails. Without this, now nothing fails, everything is perfectly fine, but internally there is no user possible, because the map is again an operation which is going to get a name, but it is null, so it is empty for you. The last is the local date time. Is it the real time? Now you would say, if it is a local date time, I get the current time. So yes, local date time represents the time. Answer is not always true, because with local date time, you get the time without a time zone. And 90% of us knows the reason why time zone is very important. Because our code does not run where you are just generating a piece of code, right? If you are writing a code in India, there might be the case that the users for this particular system or app might be sitting in US. So if you say today is 10 p.m. at night, it might be 10 a.m. at morning in US time. So without the time zone information, you are lost. So I'll give you an example. If this is a local date time, if you print it, you just say that, oh, it is 10th January 2026, 10 p.m. at night. But where? In India, in New York, in London? Answer is no clue, because local date time does not store any zone information. And this breaks the real system, because If you save the local date time and time zone and the system who reads it is in US, now the event has moved by many hours. Nothing crashed, no exception. You're simply data is giving a wrong answers. This is the worst kind of bug you can ever introduce in your system. So if you're working in an application which is cross countries where time zones are different, local date time is a disaster for you. So local date time does not represent the real moment in time. It is just a date time without any zone information, which makes it unsafe for distributed systems. Now I have many more things to cover. Are the three thread safe? Do we have lambdas or just a syntactic sugar? Does the peak always execute? And many more things to cover. Let me know if you want the second part of it. Thank you.